All right, so this section had a little bit more to it than cleanliness. We've got a few things to worry about here. We need to estimate how normal our distribution is, take a look at the linearity or linear relationship assumption, and then the equal variance across all values of x's. So let's start here with the normal distribution. A lot of these we already have, and you may just not have realized what they were yet. So let's go to Tableau and throw one of our numeric features back in there. And remember, we learned how to use this summary card before. We've actually already got, we need to change, we need to disaggregate. So let's deselect that. There we go. We've got our averages, our mean, our standard deviation, and our skewness and kurtosis scores. Let's start. Let's plug all of those in, and then we're going to generate a chart to go along with this. So average. Let's go back here. Average age. Well, let's put this all in right here. We call it mean, standard deviation, skew, curt. All right. What does that mean again? 39.21. Standard deviation. Whoops. Come on. Standard deviation 14.05. Skew. Wow, that's an impressive skewness. Really close to 0.06. And they've called this excess kurtosis. I don't like using that, but whatever. It'll work. The difference between this and kurtosis, the kurtosis of a normal distribution should be 3, and so excess kurtosis is the actual kurtosis score minus 3. So in this case, the actual kurtosis, which I like using better, is this plus 3. But I think I'm going to do that. I don't like using that score. So 3 plus that is going to be 1.76. 1.76. Okay, so we've got those metrics, but I also want a histogram. So we've got age here. Let's go click on the Show Me card to see about charts. So here's what it's given us. Here's our histogram chart right here. And it says, oh, we can't, this isn't going to work. But it says for, that's not what we want. I think what we need to do is either move it up. No, that's not it. We need to re-aggregate again. Yeah, I guess that's it. Okay, so we re-aggregate to get the histogram. And what it does is it has a formula. There's lots of different formulas for determining bin size. So in this case, bin size, it's determined we need total number of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 bins. That's based on the number of cases and the range of the data. But again, there's a lot of rules for that. We're not going to worry about going into any of those right now. We're going to keep it simple. And we just want to copy this chart. Now, looking at this chart, this explains some things. Well, the kurtosis, or excess kurtosis, you can see it's kind of a flat curve. It's not a nice, sharp, normal distribution. However, kurtosis is a problem that we can actually live with when it comes to making predictions. That's not as big of an issue if we violated the assumption of kurtosis. What concerns me more is when skewness is a problem. However, ignore this score. This skewness and kurtosis, by the way, is based on age being binned. And so see how all these other scores have changed. We don't collect these scores when we're in this aggregated mode. We collect them when it's disaggregated. So ignore all of these anyway. This kurtosis is actually not positive. This is negative because it's flat. But anyway, what this tells me, the kurtosis really isn't a big issue. Skewness, is it symmetric around the mean? Well, what is the mean again? It is 90, well, no, sorry, wrong data. Let's go back to our Word document. The mean was 39.21. So the mean was right about here. Is there a fairly even or similar distribution on either side of the mean? Is the mean very close to the median? That's another question. Well, mean is 39, median, boy, was that really 64? Oh, I got these mixed up, didn't I? Oh, yeah, I did. Well, that took me a while to catch. So let's go back through here and fix those. Median is clearly 39. Q3 is 51, and max is 64. You've probably been wondering since the last video if I was ever going to fix that. Got it fixed. Okay. So, yeah, the mean is very close to the median. which tells me that I'm going to have good symmetry around the mean, which means skewness is going to be close to 0. That tells me I trust this variable. It meets the assumptions of normality, and I can see it both in the histogram and in the skewness score right here. So I'm happy with that variable. I'm going to save this chart. I'm going to call this one age hist, or maybe hist age, keep those together. And I want a copy of this. I want to put it in my data description report. So I'm going to right click here and say copy image. What do I want it to look like? Do I want all those summary tiles? You know what? Yeah, why not? Actually, no, these ones are crap. They're to do with the bin, so I don't. So all I want is title view. Well, let's see what this looks like. Let's copy it. So I'm going to come over here and after my table, just paste that in. So hist age. Yeah, I should probably give it a better title. But it didn't include my summary card over there, which is good. So what I'm going to do is come back over here and just say, oh, I see, it's using the sheet name. No, I'm not going to use that. I'm just going to say histogram of age. And may as well center that. I'm going to make it a little bit nicer or bigger. 28, sure, why not? Okay, that's better. If you want to, go ahead and customize your other axes. I'm just going to call it good right there. Copy image, okay. Come back here, paste that in. So in my data description report, I'm going to go ahead and put in, for univariate properties, a histogram for every feature. Now, you can also, a box plot is another useful visualization for univariate metrics, or another useful univariate visualization, but we're going to keep this simple for now and just stick with the histogram. Typically, they give us a better idea of the normality anyway, although the box plot can as well. Usually the histogram does a better job of showing it to us. So go ahead and pause the video and generate histograms for each of the other numeric features. All right, I've gone through and I've made my histograms for BMI, children, charges. One thing I forgot to mention before is that we want to go ahead and get our mean, standard deviations, and skew for the rest of those as well. Let me show you a quick way to do that so that you don't have to pull these out of there. Because remember, we had to get those with deaggregated data. So I still need to do it for, let's see here, BMI. Let's do it for that. So let's go to the BMI page. What I'm going to do here is grab another copy of BMI out to the rows. Go to Analysis, Disaggregate Measures. Notice now that it still allows the histogram and shows it properly here. So I'm going to leave this deaggregated now, and that'll work just as well. But come over here to Worksheet, and notice because we're on a new worksheet, we still have to go back and show the summary again, and tell it to go ahead and show us the standard deviation, skewness, excess kurtosis. There we go. All right, and we're looking at the one for sum of BMI down here. Yep, that's what we want. So average 30.66. That's a good group. All right, 30.66 here. Standard deviation 6.10. Skew 0.28. That's a good looking normal distribution. And then excess kurtosis, negative 0.06. Yeah, great kurtosis there. Oh, but, oh, sorry, +3. It's actually, I think that's right. I think that this excess kurtosis is actually kurtosis. I'm going to change that on these other ones here back to 1.24. I think it's kind of confusing the way they call it that. So this one's actually that, and this one's actually 1.6. Okay. So I'm just going to, what they're calling excess kurtosis is what I typically use, just refer to as kurtosis. All right, so let's format our table here, see if I can make this look any better. I think for univariate properties, that's all we need. We're not going to need these other columns I added out here. So I'm going to go through and delete those. Table, oops, layout, delete, column, column. There we go. That looks a bit nicer. Okay, we can move things around to make that negative. There we go. Okay, this is a good summary of univariate properties. We've got our histograms down here for the numeric features. This is a great univariate analysis for the exploratory, for the data understanding phase. So what I want to move on to next is I'm going to call this our data description report. And let's see our charts. We can probably make these a bit smaller. With this there, let's do this. Let's shrink this down. That'll fit now on the page above. And what I can do here is add another, insert a layout break, insert another continuous break so that this section can be back to portrait again. There we go, histogram of age. And then the rest of my histograms I'm going to shrink down to something a bit more reasonable so I can fit them all nicely. Okay, there we go. And you know what? I bet I can fit this on that page above too. No, not quite. Sorry, I'm wasting precious video time here with my obsessive compulsive formatting. There we go, got it. All right. Let's, down here, I'm going to, I'll call this good, save my data description report. And now I'm going to make a data exploration report in a new document. Data exploration report. So if I'm following the CRISP DM process, then I divide my univariate and my bivariate analyses during the data understanding phase into these two reports. It's kind of a good way to indicate the difference between them. So the data description report, all of our univariate properties, including a data dictionary, and I think this is good right here for that. And now our data exploration report, this will be our all of our bivariate statistics and visualizations. So I'm going to close out my description report now, and let's move on from the metrics and visualizations for a normal distribution to our assumption of linear relationship. So a linear relationship refers to the bivariate relationship between two variables, a feature and a label, actually only between all possible features and the label. So what we're looking is to see if there is a straight line relationship there. Now, I'm going to actually save this one, including the scatter plot for homoscedasticity here, for the next section when we get into relationships. However, the White's test and Bruce-Pagan test, these are tests that it's a little complicated to do in Tableau, and your instructor may or may not require these tests of heteroscedasticity, but I'll add a video here below on how to do this in Excel. But to keep things simple, you may also just want to simply look at scatter plot. But once again, let's save that scatter plot for when we get here into the relationships, and we'll include testing for these in our data exploration report. So we'll end right here for now.